Good morning. Today's lecture is about solubility of drug. Solution is a mixture of components which are physically and chemically homogeneous. When you add solute into the solvent, it is converted into a solution. The examples are sugar solutions and saline. Solute is nothing but it's a component which are present in the solution is called it as a solute that dissolves in solvent. In the case of sugar solution, sugar is a solute and water is the solvent. So solvent is the medium in which the components are dissolved is known as solvent. If you see the saline, so water is the solvent, sodium chloride is the solute. So solubility we can define as ability of a substance to dissolve in a solvent is called it as the solubility. So the maximum amount of solute we can dissolve it in the solvent. So saturated solution is a solution which contain maximum number of solute at a constant temperature is called saturated solution. Supersaturated solution is a solution which contains more of the dissolved material than could be dissolved by the solvent under normal circumstances. Unsaturated solution is the solution where the solute concentration is lower than its equilibrium solubility. If you see the images, you can identify so what is unsaturated solutions. So unsaturated solution, very low quantity of substance is present in that. Still, you can add more quantity to make it to dissolve in that particular solvent. In saturated solution, we have added more quantity of solvent, more quantity of solute in the particular solvent, and now it is visible with each other and it is converted into a solution. Whereas in a supersaturated solution, so it is the quantity which require more number of solute which is added into the solvent than the minimum maximum number required to dissolve in that particular solvent. So these are the images to represent the solubility. So the first image we have taken solvent in the beaker in which we are adding the solute. So after the solubilization, so the second beaker you can see that completely the solute is miscible with that solvent. It is dissolved in that solvent. So now it is converted into a solution. This is the solubility curve. So in this case, in the temperature is taken in the x-axis, whereas this solute concentration which is taken on the y-axis, that is grams of solute per 100 grams of water. So depending on the substances, there is changes in the solubility. So some cases solubility will decreases when you increase the temperature, and certain products when you increase the temperature there is a increase in the solubility. For example, this potassium nitrate, so you are increasing the temperature, so now the solubility is increased. So from approximately 12 grams to 150 gram, you can increase it when you increase the temperature to 70 degrees Celsius. So and so certain cases there is a decline in the solubility. So when you increase the temperature, so one example is sulfur dioxide, you can see that there is a decrease in the solubility when you are increasing the temperature. Solubility expressions. So number of parts of solvent which require to dissolve one part of the solute which is given. So very soluble, it's less than one part is sufficient to dissolve the solvent. So dissolve the solute. In freely soluble cases which requires 1 to 10 parts, and soluble 10 to 10 parts of solvent is required to dissolve that same quantity of substance, and sparingly soluble 30 to 100 parts which is required to dissolve that substance. In slightly soluble it need 100 to 1000 parts to make it solubilize that solute, and very slightly soluble 1000 to 10,000 parts. And practically insoluble, more than 10,000 parts is required to dissolve that particular solute. So now let us see the percentage terms used in the solubility. So percentage weight per weight, this is the symbol you might have seen when you represent any type of, when you prepare any solutions, we will use percentage weight per weight or percentage volume by volume or percentage weight per volume. So the first case, it is W by W is the percent weight per weight, its number of grams of solute dissolved in 100 grams of solutions. The second one, percentage volume by volume. So this number of volume of solute dissolved in the 100 ml of solution. The percentage weight per weight that is number of grams of solute dissolved in 100 ml of solution. And some other quantitative terms also we are going to see here. The molarity is defined as the number of moles or gram molecular weight of solute dissolved in 1 liter of solution. Molality is the moles of solute dissolved in 1000 grams of solvent, and solubility of gases in liquid. Here the concentration of dissolved gas when it is in equilibrium with some of the pure gas above the solution is called solubility of gas in liquid. Carbon dioxide in water or nitrogen as propellant in an aerosol. Now let us see the factors affecting solubility of the drugs. The first factor is temperature. The more solid dissolve, the absorption of heat. When the solubility of such solid increases, the temperature is increased. However, certain products, it dissolves, so when solid is dissolved in a solvent, that is the evaluation of gas. So when you increase the temperature, it causes decrease in the solubility. The examples potassium nitrate and sodium chloride. So the next factor we are going to see the molecular structure. There is a slight modification in molecular structure of solid which results the changes in the solubility. So esterification of drug results solubility declining. If weak acid is converted into its salt, its ionic dissolution in water increase in the interactions between the solute and solvent leads to the increase in the solubility. The example is chlorophenicol. It's bitter in taste. So now we are converting into chlorophenicol palmitate. So it's tasteless now. So anyone will prefer to have this substance since it's not a bitter. So we are converting into another form. So erythromycin is converted into erythromycin propionate. So the next factor which affects the solubility is particle. So when the particle size is small, then the surface area is large. So which results in increase in its surface free energy with increase the solubility of the drug. So griseofulvin is one of the example. So when you decrease the particle size, there is surface area is more, so solubility of the drug is more for this case of griseofulvin. Nature of solvent and co-solvent. We are adding third substance to increase the solubility of the solid in liquid. So that substance is called it as a co-solvent. Addition to solvent, we will add the another solvent, that is co-solvent. So poorly soluble drugs are dissolved in a mixture of water and alcohol. Effect of complex formation. When a complex is formed, it results in increase or decrease in the solubility. So for example, iodine in water which results in increase in solubility when you add potassium iodide. So due to the complex formation of potassium iodide. So benzoic acid is added with the caffeine. In this case, solubility is decreased because of its complex formation. Solubilizing agents is the another factor which influences solubility. So we are using surfactant to increase the solubility of the solid in liquid. So when you add the surfactant, there is the decrease in the surface tension. Propylene glycol as a surfactant when added to a solid form in liquid medium, which increases the solubility by increasing the intimate contact of solid with liquid medium. Intimate contact by increased by decreasing the surface tension. Effect of pH. So most of the drugs are either weakly acidic or weakly basic in nature. So therefore they are less soluble in the water. But the salt form is greatly soluble in the water. So we are converting into a salt form to increase the solubility. Carboxylic acid forms soluble salt with hydroxides, carbonates and bicarbonate. Effect of additives. When large amount of additives are added, then the solubility increases and the process is called hydrotrophy. So large amount of sodium benzoate which increases the solubility of caffeine. So the next factor is common ion effect. The solubility of sparingly soluble salt is decreased by addition of another salt. So both these substances carrying the similar ion, so it's called it as a common ion effect. When the common ion is present between the two salts, it results in decrease in the solubility. So aluminum hydroxide added to the aluminum chloride, because of its common ion effect, there is a declining solubility. Effect of electrolytes and non-electrolytes. There is a decrease in the solubility of sparingly soluble salt in water when a non-electrolyte like alcohol is added. Due to the reduction in the dielectric constant, when an electrolyte is added, the intermolecular force will decrease the solubility of non-electrolyte. The example is precipitation of proteins. Thank you. We will continue in this next lecture.